Dave, and I worked on one of the exhibition projects. I was by myself, and so I kind of got to decide everything on my own. It was probably easier in many ways than the whole project. But what I was doing was integrating two existing pieces of technology. I was taking an application that already existed, a Lunar tuner application that is basically an instrument tuner. So when you're tuning up an instrument, you play a string on a guitar, or you play a note on a flute, or some other instrument, and you want to make sure that that's in the proper pitch. So that's what this program helps you to do. It already had a number of usability features in place. For example, you'll see this button that when pressed, will enable the speech aspects of this program. So it'll read out the settings that you place on the program. What this didn't have was a speech recognition component, so a natural language speech control for the overall application. So that's what I added. I used an existing natural language processing system called Sphinx from Carnegie Mellon, and I integrated that into this application. So I'll just give you guys a demo. It's all voice controlled now. So set instrument harmonica. You'll notice that it changed to harmonica. Or set instrument guitar. Play it. And so, all the buttons that you have that someone who was visually impaired would have to click, you can now activate via voice. Set note E. Play note. You guys can't really hear that, but it's playing now. The overall problems that I faced in doing this was basically just learning two existing pieces of software in order to integrate the two. What I ended up doing was I took the existing application pretty much as was. I had to add a couple of methods to access certain features of the user interface. And then I ran a separate thread to constantly be polling for voice recognition. The grammar that I established would control each of the features of the user interface, and then I put the whole thing together via the methods that I created to access these components. So a lot of the base functionality was there. It was more a matter of putting this second thread in place and refactoring the overall architecture of the software system to include a speech recognition system. You guys have any questions, I guess?
So you have a separate service going on that speaks to the application basically?
Well, it's not a separate service, it's a separate thread in the JVM. So it's all Java-based. And so unlike a number of applications that you might have seen that do portions of this either with speech readout or something else, it's OS independent.
Okay.
So both the language recognition and the speech out are both platform independent. And there's no training required either. So someone can use this pretty much out of the box.
Well, it's not an independent process. It's just another thread, basically.
It's another thread in the JVM, so it's the same OS thread.
Okay.
How large is the Sphinx package? Like, let's say someone wanted to download
The total package for everything that we see here is about 40 megabytes. The Sphinx package is the lion's share of that. We should probably turn it off while we're talking. So. Okay, and a couple of cool aspects of that program also is that it's all XML configuration driven. So in order to add a new instrument, you just have to edit a text file now to give an instrument name and certain other metadata about that instrument, and also frequency and phonetic pronunciation of each of the notes that you'd like to tune to. And this program will automatically modify and dynamically generate a grammar in order to allow you to set the notes automatically. Anything else? Yeah.
Hey, David, can you show the grammar file? You
Sure.
can talk a little bit about that.
Yeah, no problem. Let's see. So this is the grammar file, and you'll notice it's a Java speech grammar syntax. So it's actually it's packaged with Java itself. So this is something that you can freely download as an extension, I think, of the JDK. The grammar is pretty simple. Just for every command, you'll see in brackets these are optionals, and there's or logic here, and then in parentheses, one of these is required. So these are sub-rules in the angle brackets. So what you'll see to read this is, for example, set octave up, for example, is a valid sentence in the grammar. What Syncs does is it allows you to build this grammar, and then it actually handles all of the rankings, and what it'll do if you speak a sentence that's valid within the grammar, it outputs the text of what you spoke. So you can then parse that and add application logic, which is essentially how I did it.